Okay, so we're being recorded now. So it's April 8th, and this is CS 207. And today we're going to do the final exam review. All right. So first of all, the final exam is on the 20, 24th. So the final exam is on the 24th. Okay. So final exam, and that's on the 24th of April. Okay. If you're having trouble seeing the board, just maximize my window. Okay, and all you have to do that is you have to right click on my window and then press spotlight video, and that'll work for you. Okay. So just gonna talk a little bit about the final exam. How many of you have had a final exam from me before? There's not a whole lot of you in here, but just curious. Anybody ever had a final exam from me before? Doesn't look like it. Okay, that's fine. Yeah, so the final exam in CS 207, it's not, I don't like to do exams that are rote learning. So what rote learning means is that have you memorize a bunch of facts and figures, and then you have to just spit it back out at me. I'm not in the least interested in that. What I'm interested in is that you are able to apply what you have learned over the semester. I'm more interested in that than whether or not you remember, say, for example, what's the difference between a passive and an active transducer. So, although those are good things to know, okay, I'm more interested in your ability to apply what you have learned over the semester. So what we're going to do is we're going to, on the 24th, I will give you a copy of the exam. I think the way that I'm going to do it in here, and I'll let you know the exact format of the exam when it gets closer to the date, but what I think I'm going to have you doing here is I think it'll be hosted in Schoology. So I'll give it to you through Schoology, and you'll have so long to complete it, okay? And so the final exam is scheduled for what time? 2 o'clock in the afternoon, so 2 p.m. And so you'll have a few hours to finish it. Okay. If there's any concerns with the exam, say that maybe I know some of you might have, I know that some of you might have accommodations or something like that. If there are any concerns with the exam as far as that goes, please do let me know as soon as possible, and I will try to address that. Okay. Any questions right off the bat before I start doing the review? Okay, feel free to unmute yourself, and you can raise your hand and then I'll call on you, and then you can unmute yourself and then just ask questions if you have any. I'm going to try to keep an eye on the chat as well, but it's a little bit difficult because I can't really see that window from here. Okay. Well then, without further ado, I'm going to, this is at 2 p.m. by the way, 2 p.m. Okay, and it will be on Schoology. All right, so let's just go back to about the beginning of the semester. So the first thing that we really talked about was we gave you a basic introduction to electricity, to electronics, right? So one thing that you might need to know is how to, well, not that you might, one thing that you should know, and one thing that I will want you to know is how to read and write a schematic, okay? So that will be something that you should know. So reading and writing schematics. Writing schematics. Okay, so we covered various components. We talked about resistors. Resistor is the most common component. They look like that when represented in a schematic. So this is, as you know, a resistor. Okay. We also talked about power sources, batteries. So a battery looks something like So I'm just going to write voltage source looks something like, usually like this. What am I drawing? Oh, yeah. So a battery will usually look something like, maybe like this, right? Or the way that I usually draw it is I draw it with two non-equal lines, so like that. Okay, so that's a voltage source, battery. Okay. Another thing we talked about, of course, was a capacitor. We haven't really covered a whole lot about capacitors in this class, and that's okay. Capacitor looks like a voltage source, but it's not. So capacitors, we also talked about ground. So ground, of course, is denoted by a symbol that looks like that. Okay. And we also talked about transistors. And transistors are, well, depends on what kind they are, but they will look something like this. And of course, depending upon what type of transistor it is, you will have it either pointing inward or pointing outward, right? So those are two different types of transistors. You don't necessarily need to memorize the two different types of transistors, but no, the mnemonic is NPN never points inward, and PNP points inward positively. Those are the mnemonics to remember those. So transistors. Now the other one that we talked about are diodes. So of course a diode itself just kind of looks like this. You can draw it like this if you like. Okay, you draw it like that if you like, with a little line on one side, or the way that I usually draw them is as an arrow that's pointing one way. So like that. So that was a diode. Okay. And now if I draw little squiggly lines coming off of this thing, what do we call that? What do we call that? An LED, very good, light emitting diode. Okay, so diodes, of course, are one-way devices, right? And so the idea is that you can control the direction of current with the diode, or at least prevent it from going the wrong way. So this is an LED. So these are the important ones to know. Questions about that? No? Okay. Oh yeah, also, forgot to, if we have a arrow across our resistor, what's that? What is that? If you have an arrow across the resistor, what is that? A variable resistor. Yeah, very good. Okay, a variable resistor. And of course, there's multiple different types of variable resistors. You could also call this a potentiometer, but the idea is that if you have an arrow going across it, it's some sort of variable resistance. Okay, cool. So this is the reading and writing schematics part. So you should be able to read and write a schematic. If I throw a schematic at you and ask you a question about it, you should be able to tell me, like, what is it and what does it do? Here, I'll just throw an example at you. So here's an example for you. A very simple example. Okay, so what do we have here? What do we have here? What is this?
It's a simple circuit with a resistor and an LED.
Yep, exactly. So it's just a simple circuit with a resistor and an LED. Now it's a flashlight. Because what's this?
Yeah. It's a button, a switch button?
This is a switch, yeah.
Switch,
Usually if it's a push button, it'll look something like this. That represents a plunger. Somebody was asking me privately, saying that they need some help with their project. We can talk about that, like, message me, email me or something. If you haven't emailed me already, email me, and then I can address it. Okay. All right. So that is very simple. I hope that makes sense. Another thing that might be useful is to be able to look at a breadboard, right? Be able to look at a breadboard and then to be able to translate that into a schematic. That might be something useful. Okay, so going from a breadboard to a schematic. That might be something I ask you. Okay, so that's the electricity part. Any questions about that? No? Okay, that's fine. All right, so after we got done talking about electricity, I introduced the idea of the interactive hardware model. Okay, and so the interactive hardware model, of course, has a few different components. Okay, so what do we have here? Input. Okay, and what do we have here? Processor. Then here, memory or storage. Then finally, an output. Yeah. Okay. So it might be a good idea to know this. Just a hint. It might be a good idea to know this. All right. So of the components in the interactive hardware model, which ones are transducers? Which parts do the transduction happen? Where does the transduction happen in this model? Nope, the processor is not where the transduction happens. Okay, so give me an example of a transducer. Yeah, so input and output. So input and output, this is where transduction occurs, okay? So I think maybe we need to revisit that idea. Okay, what is transduction? I gave you a few different definitions for transduction. But what is, I mean, give me probably the one that I use the most. What is transduction? You can either go on the microphone or you can type it in, I don't care. Bueller. Bueller. Yeah, okay. So, yep, you're about right there. So transduction is the flow of information, but it's the flow of information It's not quite complete yet. The flow of information where?
Flow of information from one form to
I
another.
can't hear you guys. Speak up.
Flow of information from one form to another.
From one medium to another, I would say.
Yeah.
Yeah, so from one medium to another. From one medium to another. Of course, a medium is an information carrier. Okay, so when we talk about multimedia, we're talking about multiple forms of carrying information. That's where the term medium is what medium means in multimedia, right? Is different channels of communication. Okay, so medium means that. So there's a difference between information. Of course, there's a difference between information and there's a difference between information and data, right? So what is information then? What's the definition of information? There's a couple of different definitions that are equally valid. Anybody remember at all? Anyone want to take a guess? No? Yes? I can stand here all day. Analog and digital. Analog and digital are two different, I guess, forms that information comes. Well, no, technically not. Analog and digital are technically not two different forms of information. This information really only comes in one form. I'll help you out here. What's the basic unit of information? What is information measured in? Bits, yeah. So bits is the unit of information. Okay. Now a bit is binary, right? So either it's a 1 or it's a 0. Okay. So if information, the basic, if the fundamental unit of information is the bit, and bits are necessarily binary, what does that tell us about information? That information has to be binary. Okay, yeah, so information is binary. That's because information is the answer to a yes or no question. Okay, it's the answer to a, nobody asked you, Google, or no question. Okay, it's the answer to a yes or no question. Now, the other definition would be the resolution of uncertainty. That's the second definition, or the resolution of uncertainty. Resolution of uncertainty. Okay. Now, information and data are related, right? Data is what we use in order to gain information, right? So I can ask you a question like, is it hot in here? You look at the thermometer, you'll read that it's, well, hey Google, what's current inside temperature?
Nest is off and it's currently 21 degrees.
So it's 21 degrees in my room, in my house right now, which is a little bit too warm for me. So if I asked you, is it warm? If you asked me if it was warm, I would give you a yes or no answer. That's information. I would say, yes, it's warm in here. 21 is pretty warm for me. Some people it's cold, but I'm pretty warm. Anyhow, the answer to a yes or no question, resolution of uncertainty. Okay, so we talked a little bit about information and about the theory behind information. Okay, we talked a little bit about Shannon, talked a little bit about entropy. We didn't go very far into it. If you're interested in that sort of thing, we do teach at the graduate level information theory, which actually I'm teaching over the summer. So, of course, that doesn't really apply to any of you unless you're graduating this semester and going to be in a master's program next semester. So, transduction. Any questions about transduction? Okay. Cool. All right, moving along. Okay, so next topic. Actually, let's talk a little bit more about transduction. Just a little bit more about transduction. I said that there are two different modes of transduction. Of transducer, I should say. And the two modes of transducers are, first of all, there is inputs and there are outputs. Inputs and outputs. So these are two different modes of transducers. Okay. There are also two different types of transducers. And the two different types of transducers are active and passive. Okay. And so we talked about active and passive transducers. An example of an active transducer would be something that, well, the definition of an active transducer, I should say, would be some device that generates, should I put this? It generates electricity in a circuit. So an active transducer actively generates electricity in a circuit. It actively introduces electricity into a circuit. Whereas a passive transducer responds to outside information. It responds to external stimuli. So for example, a generator would be an example of an active transducer. A generator, of course, when you crank it, it creates electricity. It takes the information, the rotational information, and converts it into voltage. Now, a passive transducer, on the other hand, a passive transducer is a little different. The passive transducer, an example might be a piezo disc. No, I lied to you. Piezo disc is an active transducer. Passive transducer might be something like a photoresistor. So a photoresistor doesn't actually generate electricity, it modulates a signal, right? So by changing the amount of light, the resistance will increase or decrease. So that is a passive transducer. So you've got active transductance and passive transductance. You have two modes of transducers, inputs and outputs. Okay. So that's really all I want to talk about when it comes to transduction. But remember, transduction is an important concept. So it's probably the second most important concept. Okay. If you have any questions, please let me know. I'm just going to keep going. Okay, so the next two sections that we talked about were inputs and outputs, right? So we talked about inputs, and we covered a number of different inputs. So there was like push buttons, for example. The binary detects binary information, and then there's a potentiometer. Talked about that, which is a device that changes voltage depending upon how far it's turned. We also have stuff like a photoresistor, and so on and so forth. Now, the idea behind an input when it comes to these types of systems, the idea behind an input is that you are taking information from the outside world, right? And you are trying to bring it into the electrical system by transducing that information into something that is compatible, that is computable. Okay, so we're trying to take non-computable information and make it computable. I should say non-electronically computable information and make it computable. So that's the entire idea behind input transductance. Okay. So those are inputs. Then we talked about outputs. Okay, outputs, also known as actuators. So actuators, outputs, are things that act, right? They're things that will take information from the system, and will convert it into some sort of a non-computable form. So they will affect change on the outside world. So for example, an LED, right? An LED or a motor. Or really any other type of, you can have a buzzer. These are all devices that will take a electronic signal and will convert it into a physical form, right? Something that's in the outside world, something that's in the real world, not just inside the chip. So, outputs. Of course, once again, inputs and outputs are very closely related, right? Depending upon what mode you have a transducer in, it can either be an input or an output. And there are some that flip back and forth very quickly. Like for example, a temperature meter becomes a heater very quickly if you change the direction that the electricity flows. Right? If you change the direction that the electricity flows, it becomes a heater. So that's all I want to talk about with inputs and outputs. Okay. So the next thing that we talked about, so we talked about processing. So processing. Okay, and we talked about how transistors work, and that transistors really are the fundamental building block of digital electronics. Okay, transistors are the building block of digital electronics, and that's because transistors work as little switches. They work as little electronically controlled switches that can flip on and off. And so transistors are the fundamental unit when it comes to processing. Now we also talked a little bit about ways of bypassing the fact that we have a single core processor. So we talked about microcontrollers and the fact that they, like the ATmega, is the one that's in the Arduino, and the ATmega has a single processor. And because it has a single processor, it cannot multitask, so we have to come up with some tricks in order to get it to multitask, in order to do two different things at once. Otherwise, for example, it'll be blink without delay. Otherwise, it gets held up, right? And it will not be able to do two processes at once. Okay. So that is processing. And then I talked about a couple of other chips. Actually, I should probably maybe cover a little bit of that. So I covered a couple of chips. Those chips, for example, are the 555 timer. 555 timer. We also talked about the H-bridge. We also talked about the shift register. We also talked about the Texas Instruments 7400 series. Okay. But eventually we wound up talking about microcontrollers. And what makes microcontrollers unique is that they have both a processor, they have storage built in, and they also have input and output peripherals. So they can basically satisfy everything in our interactive hardware model. They're a little tiny self-contained computer. That's what's really cool about them. So they're a little self-contained computer, and they have everything that we need in order to interact with the world. So it's really cool, and that's one thing that really attracts me to microcontrollers. I think they're really cool. Okay, processing. Now, after we talked about processing, we then talked about communication. Specifically, we talked about serial communication. Okay, so there are two main categories of serial communication that we talked about. What were those categories? What were those categories? The two main categories we talked about when it came to serial communication. Nobody remembers? Does anybody remember what serial communication is? What do we mean by serial? What's the difference between serial and parallel? These are good to know things. What does serial mean? Give me that one at least. Anyone. This is really awkward because I'm standing in this room talking to myself. One after another. Yeah, so serial means one after another. Okay, and so the two main categories of serial communications that we talked about were wired and wireless. Okay, so we talked about various wired serial protocols, and I talked about the general wired serial protocol. We talked about the USB protocol. We talked about I2C. We talked about SPI. And then we talked about wireless protocols. There's lots of wireless protocols: Wi-Fi, Bluetooth, NFC, RFID. We even talked about Li-Fi. We talked about data over audio. Okay, so these are a bunch of different types of serial communications. Okay, so we don't need to rehash a whole lot of that. All right. Now, the last category we talked about was, of course, storage. Okay. And so one of the things that really the take-home message when it came to storage is that the 18 mega has a very limited amount of storage. Right? It's very limited. And so there are a number of ways that we need to get around this limitation. Of course, before we say anything about that, we should talk about the different pools of data, of storage on the 18 mega. So there are three different main pools. There was, of course, the flash ROM. There was the EEPROM, and there was the SRAM. Okay. Now, these first two categories, they belong to the same category. What is that category of memory? So there's two main categories of memory. So these two belong to the same category. What category is that? What do these two belong to? Well, here, I'll ask an even easier question. What are the two categories of memory? Yeah, non-volatile. Good. So these ones are non-volatile or static. Okay. We'll just go with non-volatile. That means that SRAM is what? These guys are non-volatile. What does that mean? The SRAM. Yeah, volatile. Very good. Okay. Volatile. Cool. Okay, so The SRAM, so we'll start with SRAM. The SRAM is volatile. Volatile meaning that when you turn off the device, all of the things that were stored in that pool of memory will go away. Okay, this is where we will store, generally speaking, this is where we store the variables. This is where any kind of variables that we initialize during runtime. So during runtime, we are reading and writing to the SRAM, okay, primarily. Now, the other two, non-volatile. Non-volatile meaning that you can shut off the Arduino, you can shut off whatever device that is powering it, and it will be fine. The information will stay. So, flash ROM. So flash ROM is where the program is written. Okay, this is where the program lives. We write to the flash ROM before we run the device. The EEPROM is the second one. EEPROM is kind of this weird in-between state. So EEPROM is a non-volatile memory that we have access to during runtime. Okay, so these two you can access during runtime. This one you can't. This one is volatile. These two are non-volatile. Okay, so we also talked about some of the solutions to the limitations. Okay, we talked about some of the solutions to the limitations of storage because we have a huge limitation when it comes to storage. Okay, so a couple of those solutions. First of all, I talked about different ways of programming so that we don't take up much space and we are careful with our resources. So this would be careful resource use. Careful resource use. Okay. Now, the second way that we talked about is the use of an external device. So something like an EEPROM, an external EEPROM, or an SD card. So we talked about these different methods. And then the last thing we talked about, we talked a little bit about the Internet of Things, which I'm not going to ask you any questions about. Okay. So that was our semester in about an hour, no, 45, 44, 43, 40, about 42 minutes. Any questions? All right. Well, if you have any questions after class, please do email me. You can message me on Discord if you like, although it's much safer to email me because there's no guarantee that I will respond. And if too many people message me on Discord, I get annoyed. So it's best to email me. Any other questions that you maybe want to ask for the class? Okay. Fine. Email me if you have any other questions. Okay. So thank you very much for your attention. And please be on the lookout for me. I will be giving you further instructions for the rest of the semester. Okay, so we've got, what is it? About 2 weeks until the final exam. Yeah, okay. Thank you very much for your attention. Do you have class on Friday? No, there is no class on Friday. Friday is Good Friday. So that would be not cool to have class on Good Friday. Okay. All right, I'm going to go ahead and stop recording.